I welcome you all in the next video tutorial of the biosynthetic pathways. So far we have completed the biosynthetic pathways, that is the shikmic acid pathway, and we have seen the different type of metabolites like alkaloids and flavonoids are biosynthesized by using this pathway. And now we will focus upon the next pathway that is in our syllabus, that is the acetate pathway. So let's start. So acetate pathway, or you can say acetate mevalonate pathway, or we can say isoprenoid pathway. This is very important pathway for the production of different type of metabolites. Let's read once, then we'll start. So isoprenoid pathway is also known as a terpenoid pathway or the acetate mevalonate pathway, and basically this pathway contribute about 1/3 of all secondary metabolites. So mean this is very important for the production of the secondary metabolites. The isoprene units from this pathway is contributed in the biosynthesis of different type of metabolites like terpenoids, indole alkaloids, anthraquinone, means anthraquinones are the glycosides, and the naphthaquinone derivatives. The important steps involved in this pathway are as follows. So we will see the steps. So as you can see, don't worry, these are very simple steps. I hope you are seeing this. So you might found this is very complicated, but actually this is not. This is a very simple steps are involved, because we have to give just an overview of that. Okay, suppose why I'm saying this, suppose this is a mevalonic acid here, and this is IPP, that is the isopentyl pyrophosphate, and in between there number of steps are involved. So we don't have to focus upon the each and every step, we will focus upon only the main step. Okay, so let's start again. So basically there are different type of steps involved in this. So first let me take an overview. Let me zoom a bit. So let's see what was happening here. As you can see here, this is a biosynthesis of the isoprenoid compounds, means we will produce the volatile oil containing compounds. So suppose acetate, this is acetyl coenzyme A. Okay, so this become acetoacetyl coenzyme A. Then beta hydroxy beta methyl glutarate coenzyme is produced. Okay, then 5-phosphomevalonic, this is mevalonic is produced, then 5-phosphomevalonic acid, then again 5-phospho 3-phosphomevalonic acid, then IPP isopentyl pyrophosphate, GPP that is geranyl pyrophosphate, and FPP then farcinyl pyrophosphate is produced. Okay, so now we will start it's in detail. So let's start. So what happened in the first step? Look at this. Acetate mevalonate pathways begin with the molecule of the acetyl coenzyme A, and we know this is produced in the glycolysis as an end product. So what was happening here? The first two molecule of this acetyl coenzyme A, it forms acetoacetyl coenzyme A with the help of the Claisen condensation reaction. As you look at here, that is a Claisen condensation reaction. What was happening here? It is a carbon-carbon bond forming reaction that ultimately form this beta ketoester or diketone derivatives are produced. This is a simple representation of the Claisen condensation. Again, I am repeating first step. So it will start with this molecule acetyl coenzyme A, and two molecule of the acetyl coenzyme A, it form acetoacetyl coenzyme A through this Claisen condensation. Just see here, this is the acetate, then here it is, this is acetyl coenzyme. Okay, and here it is, again acetyl coenzyme is there, so it will form acetoacetyl coenzyme A. So this is our first reaction. See again, acetate, acetyl coenzyme is produced with the help of this enzyme. Okay, and we know that is CoA as such is nothing but it is a coenzyme A. See again, then it will produce acetyl coenzyme A plus this again acetyl coenzyme A. So what is produced here? Acetoacetyl coenzyme A. Then what happened? The third molecule of this aceto, or you can say acetyl coenzyme A, it form an intermediate by an aldol condition, that is the beta hydroxy beta methyl glutarate coenzyme A. I hope you remember this compound also, that is HMgCoA. Look at this. This third molecule of acetyl coenzyme A, it will undergo aldol addition, okay, or aldol reaction, and it will form this, that is HMgCoA, that is beta hydroxy beta methyl glutarol coenzyme A. This is produced. Again, see here, acetyl coenzyme A, it will go aldol addition to give beta hydroxy beta methyl glutarol coenzyme A. Now, next step is the reduction that will give rise to the mevalonic acid, which is the main precursor of this terpenoids. See here, okay, just see here, this mevalonic acid is the precursor. Look at this. This mevalonic acid is the precursor of what? Steroids and isoprenoid. And we know the basic unit of the terpenoids are the isoprenoids. Okay. So the mevalonic acid on ATP mediated phosphorylation resulted into the mevalonic acid diphosphate. Just see here, mevalonic acid, it will undergo ATP mediated phosphorylation to form mevalonic acid diphosphate. See here, when you see here, this is the mevalonic acid support, COH, CS2 again, it will undergo this ATP mediated phosphorylation. Just see here, what is the difference between these two structure is at this point, it will form CS2OP, that is the 5-phosphomevalonic acid. Here it is CSCOA, it will convert it into CS2OP. Okay, then again it will undergo ATP mediated phosphorylation, it will give again CS2OP becomes CH2OPP, rest or the remaining structure will be the same. So what happened here, the mevalonic acid on ATP mediated phosphorylation resulted into the mevalonic acid diphosphate, which upon decarboxylation produces first isoprene unit, that is the isopentyl pyrophosphate. So you have to remember this IPP. Here you can see here, this IPP is produced by ATP mediated phosphorylation. Then this is the main compound, that is the IPP is produced. See over here also, mevalonic acid, again CS2OP, ATP, CS2OPP. Then this is one is the isopentyl pyrophosphate. Look at this structure. This is 3-isopentyl pyrophosphate. Then with the help of this enzyme, that is the mevalonate kinase and mevalonate 5-phosphate kinase, what was happening here? IPP is produced. Then isomerase enzyme, that is the IPP plus this isomerase enzyme, it will give rise to the second isoprene unit, that is the diethyl allyl pyrophosphate, that is a DMAPP. Just see here, this is DMAPP. Again, DMAPP. And what was happening here, this DMAPP is basically, again, it reacts with the IPP and it will form these type of units like C10, C15, C20 up to C40. So these type of units are produced like geranyl pyrophosphate. So geranyl pyrophosphate plus this again IPP unit, that is the isopentyl pyrophosphate, it will give this unit, that is the farnesyl pyrophosphate. Here it is again geranyl pyrophosphate plus IPP, it will give C15, that is the farnesyl pyrophosphate. And yes, these are the basic units that will produce the different type of terpene derivatives. Like for example, from GPP, it produces monoterpene. From FPP, sesquiterpene is produced. Okay, and from diterpenes, we have different type of carotenoids or gibberellins are produced. So what was happening here? GPP plus isopentyl pyrophosphate, it will give FPP. Then again plus, or you can say multiply by 2, it will give C30 units, and if it is 1, then it will produce C15, or you can say C20 units. And if you again multiply by 2, means nothing but we will add IPP units over here, that is isopentyl pyrophosphate, C5 units. And I hope you remember about the volatile oil, these are the hydrocarbons, C5H8 units. So I think this will give you an overview. Don't worry, we will do it again at least 2 to 3 times for the proper understanding. So thank you for your patience.